Good day, viewers all over the world. Welcome to Today Online class. So today we are going to continue with the properties of binary operations. So this is binary operation 2. So under the binary operation 1, I introduced the concept binary operations, and under that we have treated the first three properties of binary operation, and that is we have talked about the closure property. We've talked about the closure property. We have talked about commutative property. We have discussed them. We have also discussed associative property. So today we are going to continue with the fourth properties, and that is distributive property. And this distributive property is the fourth property. There are 6 properties that we are going to consider under binary operations. So under distributive property, we'll be talking about two different operations. We'll be talking about two different operations. That is, we are given. Let's say we are given a non-empty set X. Given that a non-empty set X is closed under the operation asterisk, and let's say an inverted triangle. So if for all A, B, C that belongs to X, if we can get A asterisk B inverted triangle C, if it's equal to A asterisk B, then inverted triangle A asterisk C. If we are able to write this, then the first operation here, operation asterisk, the first operation is said to be left distributive over the second operation. So what are we talking about here? Under distributive property, two operations are involved. So we want to check if the first operation distributes over the second or vice versa. How do we check that? If you have A asterisk into bracket B inverted triangle C, if we are able to express it in this form, and at the end of the day we arrive at the same answer, it simply means that this asterisk distributes over these second operations. So under distributive property, we'll be talking about two operations under distributive property. But in this case now, asterisk is towards the left of this inverted triangle. So that's why we said it is said to be left distributive. That's why we call it left distributive over the other one. Then we can also have something like B asterisk C, then star A. In this case now, we are going to have B asterisk A inverted triangle C asterisk A. So in this case now, we are going to say that star is right. In this case now, it's right distributive over inverted triangle. So in this case now, it is right. That is, when we check this first one, this one is at the left hand side. Here is at the right hand side. But irrespective of how we have it, we have been able to establish that it is either right or left distributive. That is, distributive property has been shown, and that is the most important thing. That is the most important thing under this property. So either left or right distributive, that is what we have. So we should also note that multiplication distributes over addition. So let's take note that under distributive property, multiplication distributes over addition and subtraction. That is, multiplication, when you have multiplication, let's say A into bracket B plus C, multiplication distributes over addition or subtraction. That is, we can have A times, here is times B, plus or minus A times C. So multiplication distributes over addition and subtraction, but the converse does not hold. That is, addition and subtraction does not distribute over multiplication. That is, we can say A plus then B times C. This is not, this will not happen. That is, we have A plus B multiplied by A plus C. This one does not hold. So plus or minus, plus or minus. So please take note that multiplication distributes over addition and subtraction. So we should take note of that, and that is in general. So I'm going to take one example now to explain this distributive property. Let's say example 1. What are we given? We are given the operations. The operation asterisk and inverted triangle are defined. These operations are defined on R. And of course, this R is a set of real numbers. Okay. By this operation are defined by A asterisk B to be equal to A plus B over 3 for all A, B belongs to R. Then we also have the second one. A inverted triangle B is given as AB for all A, B belongs to a real number. So the question is now, does the operation inverted triangle distribute over 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 the operation asterisk? So what do we do? In this case now, this is what to do. We want to know if this distributes over this. Then for this to distribute over this is how we write it. We can say A inverted triangle. We want to check if this operation distributes over asterisk, and that's what we have. If that is the case, then we should be able to show that A inverted triangle asterisk A inverted triangle C. We should be able to show this. For this inverted triangle, this operation to distribute over asterisk, these condition must hold. Then this is what we want to check. So we can start from the from the left hand side. What do we have there? We have A inverted triangle into B asterisk C. So we are going to say A inverted triangle. What is B asterisk C? You know, when we have A asterisk B, is equal to A plus B divided by 3. So here we are going to have B plus C divided by 3. That's what we are going to get. Okay? From what we are given, that's what we are going to get. That is what we get. Then from there, then what is A inverted triangle B? That is AB. So we are going to have A into bracket B plus C all over 3. So if you expand this, we are going to have AB plus AC all over 3. That's what we get at the left hand side. Then we now move to the right hand side. In the right hand side now, we have A inverted triangle B asterisk A inverted triangle C. Then what is A inverted triangle B? Is defined as AB multiplication asterisk AC. That's what we are going to get. Then what is asterisk? That will be it is plus this divided by 3. Then we are going to have AB plus AC all over 3. Therefore, A inverted triangle B asterisk C is same thing as A inverted triangle C B asterisk A inverted triangle C. So since we are able to show this, hence we can generalize. We can say hence the operation asterisk distributes over the operation inverted triangle distribute over asterisk. Why do we say that? Because when we open up here, this is what we got. Then when we do the right hand side, if you compare the two results, it's the same. That simply means that this inverted triangle sign distributes over asterisk, and that is what we have been able to show. Then we take one more example, then I'll go to the next property. So let's take one more example. Say example 2. Let's take one more example. In this case now, we have two operations, asterisk and plus, and this operation, they are defined. These two operations are defined on R, set of real number as follows. These two operations are defined. as follows. M asterisk n is defined as 3mn, and m plus n is defined as 2 into bracket m plus n. That's what we have. That's what we have. 2 into bracket m plus n. That's what we have. Okay. The question now says determine whether or not, we have to determine whether or not the first one, star is distributive over plus. The second one, or plus is distributive over asterisk. So that's what we want to show. So in this case now, we have 2 in 1. The question is 2 in 1. The first one, solution. The first one that we want to do is that we want to show either, let's say A, asterisk is distributive over addition. This is what we want to show. So how do we show this? If this is this odd, then we are going to have A asterisk B, then plus A asterisk C. So if we are able to show that this left hand side is equal to this right hand side, it simply means that asterisk distributes over addition. So let's show that. Let's show that. But if we are unable to show that, then it simply means that. So I'll start from the left hand side. What do I have? A asterisk B plus C is equal to. So here I'm going to have A asterisk. What is B plus C? B plus C is defined as 2 into bracket. That is 2 into bracket m plus n. Okay. So at the end of the day, I'm going to have A asterisk 2m plus 2n. That's what I'm going to have. Then when I have asterisk is defined as what? M asterisk n is 3mn. So here I'm going to have 3a into bracket 2m plus 2n. Then at the end of the day, I'm going to have 6am plus 6an. And that's what I'm going to get. No, here is BC, not M. This place is BC. BC. Here I'm going to have B. Here is C. Then here I'm going to have B. Then I will have C here. So that at the end of the day, I will have 6AB plus 6AC. So let me go to the right hand side. So what do I get if I apply the right hand side? At the right hand side, I have A asterisk B plus A asterisk C. So if I do that, what do I get? A asterisk B is given as what? That will be 3AB. Then plus 3AC. So when we have plus, it's given as 2 into bracket 3AB plus 3AC. So if I open up, I'm going to have 6AB plus 6AC. Therefore, A asterisk B plus C is equal to A asterisk B plus A asterisk C. So since we are able to show that, it simply means that star is distributive over plus. So we have been able to show that. So we go to the B part of the question. Will it be the same thing? That is, the second one now says, the B part of the question now says we should show that plus, that is, we should show that this plus distributes over asterisk. And if that is the case, this is what we want to show. We want to show that this holds A plus C. So if we are able to show that this left hand side is equal to this right hand side, it simply means that this plus distributes over asterisk. So now let's start from the left hand side. A plus, then B asterisk C. This is going to give us A plus. What is B asterisk C? B asterisk C will be 3B. It will be 3BC. That's what we are going to have. And at the end of the day, when we have plus simply means 2 into bracket, addition of this two, that will be 2 into bracket A plus 3BC. So at the end of the day, we are going to have 2A plus 6BC. That is what we are going to get at the left hand side. So I'll go to this right hand side. So what am I going to get at the right hand side? At this right hand side now, I have A plus B asterisk A plus C. What would that give us? So I'll just show the expansion there. What is A plus B? A plus B will be 2 into bracket A plus B, then asterisk, we are going to have 2 into bracket A plus C. So if you open up, you are going to have 2A plus 2B asterisk 2A plus 2C. That's what we are going to get. So then if you look, do asterisk simply means 3 multiplied by the 2. So I'm going to have 3 into bracket 2A plus 2B times 2A plus 2C. So this will be 3. This is going to give me 3. So we can expand what we have there. We can expand what we have there. When we expand this, I'm going to get 4A squared plus 4A, this is 2C, plus 4AC plus 4AB plus 4BC. That's what I'm going to get. So if I now multiply everything, I'm going to have 12A squared plus 12AC plus 12AB plus 12BC. And that's what I'm going to get. So at the end of the day, we realize that A plus B asterisk C is not equal to A plus B, then asterisk A plus C. So that simply means that therefore plus is not distributive. It's not distributive over asterisk. Why? Because the left hand side, the value that we got at the left hand side is different from what we arrive at the right hand side. So that is how to show if a particular operation distributes over the other. And that's what we have shown now. In this case now, we didn't get the same result. So it shows that plus does not distribute over addition. So I will go to the fifth properties. I will go to the fifth property. Then the fifth property is called the identity element. It's called the identity element. So in this case now, identity element simply means neutral element. That is, identity element simply means neutral element. For instance, if you say 1 plus 0, is it not 1? It's same thing as 0 plus 1, and it's going to give us 1. So in this case now, this one is that identity element under addition, operation addition. If you say 2 times 1, it's not the same thing as 1 times 2, and it's going to be 2. Then this one is identity element under multiplication. So if you have this operation multiplication, the identity element is 1. Then if you have this operation addition, the identity element is 0. So identity element simply means neutral element. So let's give the definition. Given and non-empty, of course we have established that in the first class, that the set must be non-empty. A non-empty set X which is closed, and the set must be closed, which is closed under a binary operation asterisk. So if there exists, this symbol for there exists, if there exists an element, E that belongs to X, such that this symbol is there exists, this symbol is such that A asterisk E is equal to E asterisk A, and it's equal to A. If you're able to get that for all A that belongs to X, then E is called the identity. It's called the identity or neutral element. Is that you call it identity element or neutral element? Okay, it's called the identity or neutral element in X under the operation asterisk. So please let's note, neutral element is same thing as identity element. That is the element that has no effect when we perform an operation with that element. So that's the meaning of identity or neutral element. So that's what we are going to have. Then let's note, it is expected that as a mathematician, we should know that the neutral element or identity element, if it exists, is unique. Just like in case of addition, the only identity element that we have is 0. In case of addition, the only identity element we have is 0. When we say 5 plus 0, the same thing as 0 plus 5, and we are going to have it to be 0. Under multiplication, the only identity element is 1. When we say 10 times 1, it's the same thing as 1 times 10, and it's got to 1. So the identity element, if it exists, it's always unique. So please let's note that. So I'm going to give example, maybe 1 or 2 examples under identity elements. Then we go to neutral. We go to the final properties. So let's say example. Let's say example 4, or say 5. Let's say example. So look at this example. An operation, inverted triangle, is defined on R, that's the set of real number, by A inverted triangle B to be equal to AB all over 3 for all AB belongs to R. The question now says find the identity element. Of course, we have been able to establish that is that you call it identity element or neutral element. So in some textbook, probably you are going to see neutral element there. It's still the same thing. All right. So we can just say let the identity element be X. Oh no, let the identity element be E. So if A belongs to R, then we said we want to represent the identity element as E. So if an element A belongs to R, then we are going to have A inverted triangle E must give us E inverted triangle A, and it must be equal to A. That's meaning of identity elements. In this case now, A inverted triangle E is what? If A is inverted triangle B is AB over 3, that will be AE all over 3. That's what we are going to get, and it must give us A. So from here now, if I cross multiply here, I'm going to have AE is equal to 3A. So if I divide both sides by A can take care of A will take care of A. Therefore, E is equal to 3. So in this case now, the identity elements. So in this case now, we now write. We now say hence the identity elements in R under the operation inverted triangle is 3. So in this question now, the identity element is 3. So the identity element is 3. So let's take one more example under this before we move to the final properties. So the question says the operation, let me just write asterisk, the operation asterisk on the set R. Of course, we all know that set R is set of real numbers. Okay, on the set R, which set of real number is defined by x asterisk y to be equal to 2x plus 2y minus 1 all over 2 for all x, y that belongs to that real number. Okay, the question now says find the neutral elements in R under the operation asterisk. Okay, so we know that the neutral element or identity element can be denoted as E. Okay, we just do this. Just say let E be the neutral element. Then what do we want to establish? We want to establish that in this case now we have X. We say X asterisk E must be E asterisk X, and it must give us X. So here, what is X asterisk E? X asterisk E here, what are we going to have? We are going to have, wherever you see Y, you change it to E. Okay, we are going to have 2x plus 2e minus 1 all over 2, and that must give us X. So here, if I cross multiply there, I'm going to have 2x plus 2e minus 1 to be equal to 2 times x, 2x. So that I will have 2e minus 1 to be equal to equal to 2e minus 2x plus 1. Take care of this, is equal to 1. So e will be equal to half. So here now, if 2e is equal to 1, then e is equal to half. So in this case now, the identity elements, the identity elements, in R under asterisk is half. So that's how to find the identity element. Then I will introduce the last property under binary operations, and that is called the inverse element. The inverse element. Of course, I said under addition that the identity element is 0 under addition. Then what will be the inverse element? The inverse element will be the negative of what you are given. That is, the inverse element is the element that you are going to operate with what you are given to get the identity element. That is, here I can say 1 plus minus 1. What would that give me? That would be 1 minus 1. It could be 0. So the inverse element is the element. The inverse element is the element that you operate with the given element to get the identity element. Under multiplication, I said the identity element under multiplication is 1. That is, if I say 3 times 1, is same thing as 1 times 3, and it's equal to 1. So what will be the inverse of this 3? The inverse of 3 will now be, what am I going to multiply with 3 that will give me 1? That's the inverse, and that will be 1 over 3. So 3 multiplied by 3 raised to power minus 1 is equal to identity. So that is just its simple explanation under the inverse element. So now let's give the definition. The sixth and the last property, the inverse element. The inverse element. So in this case now, if you are given a non-empty set X, if you are given a non-empty set S which is closed under a binary operation asterisk, if for all x belongs to S, if, let me write it here, if for all small letter x that belongs to X, if we can find an element S prime that belongs to X, such that X asterisk S prime is same thing as S prime asterisk S will give us identity elements, then S prime is called the inverse element of X in X. So this small x and S prime, they are elements of this set X. So if this holds, if you can get something like this, that is, if you have an element X and we operate that element with an inverse of that element X, if we are able to get the identity, then that simply means that S prime is called the inverse element. And we should also know that if this inverse element exists, then it must be unique. Just like in the case of identity element, if it exists, it must be unique. Okay. So for instance, if you have 3 plus 0, it's not 3. It simply means that this 0 is the identity element of this element 3. Then how do I get the inverse element? The inverse element is what I'm going to operate with this 3 under addition. That's going to give me the identity. So in this case, it will be minus 3. So my identity element under addition is just the negative of that element. Okay, that's what that is what inverse element is talking about. Let me also say this, that if you have, let's say 7 times 1 is not 7. So this 1 is the identity element of this 7 under multiplication. 1 is the identity element. Then what am I going to multiply with 7? That's going to give me that identity element. Whatever I have at here is the inverse element. So in this case, it will be 1 all over 7. 7 here 1, 7 here 7, 7 here 1, 7 here 1, 1 times 1, 1. So that simply means that this implies that 7 multiplied by 7 raised to power minus 1 is equal to identity. So this is the identity element. Identity element is what you are going to use to multiply with the element that will give us The inverse element is what you multiply with that element that will give us the identity element, and that is what we are expected to know. So I'm going to give example now. I'll give example on this now. After the example, then we can close the class. So let's say example 7. The operation asterisk on the set R, set of real numbers, of the set of real numbers, excluding, in this case now, the question says excluding zero is defined by P star Q to be equal to PQ for all PQ belongs to R. So find the inverse of X that belongs to R. So in this case now, please note that under the inverse element, we cannot find the inverse element directly. We must first find the identity element. So it is when we know the identity element that we can go ahead and find the inverse element. Even if the question, like this example 7, states that you should find the inverse element, you cannot get the inverse element directly. You must first find the identity element before we can find the inverse element. So we now say let E be the identity element. Then if E is the identity element, we are going to have P. So this X now, we find the inverse element of X. So we have X multiply asterisk E will be equal to E asterisk X, and we are going to have X. So here we are going to have X times E to be equal to X. That's what we are going to get. Divide both sides by X. X will cancel X, then E is equal to 1. So we have gotten the value of the identity element to be 1. So once we now know the value of identity element, we can go ahead and find the inverse element. So you cannot know the inverse element without the identity element. Please let's note. So we can now say let S prime be the inverse. Let it be the inverse of X. Then what is the implication? We know that X asterisk inverse is same thing as inverse asterisk X will give us identity. So will give us the identity element. So X asterisk inverse give us identity element. So what do we have here? What is when we have P asterisk Q is PQ? So we are going to have X identity inverse to give us identity element. Then in this case now, the identity element, in this case now, X prime is equal to 1. Then X divide both side by X, divide both side by X. So S prime, which is the identity element, S prime, this will take care of this. So X prime is equal to 1 all over X, and that is the identity element that we are looking for. So I'm going to give the last example. I'll give the last example, then we close the class. Okay, that is what you do. So let's take the final example for today. That's what you are going to get. Then let's take the last example. Let's say example 8. What are we given? We are given an operation asterisk that is defined on the set R, which is set of real numbers, and is defined by A asterisk B to be equal to 2A plus 2B minus 3 all over 2 for all AB belongs to R. So the question says find the inverse element, find the inverse of X that belongs to R. So in this case now, we have established that you cannot find the identity element without the inverse element, without the identity element. So we go ahead and find the identity element. Let E be the identity element. So that's first thing to do. So that we are going to have X asterisk E is same thing as E asterisk X. It must give us E. So X asterisk E, if we do what we have on the board, X asterisk E will now be A will represent X, then E to B. That's what we are going to have. Will now be 2X plus 2E minus 3 all over 2 is equal to E. So when you cross multiply, you are going to have 2X plus 2E minus 3 to be equal to 2E. That's what you get, eh? No. No, this will give us x. Here will give us x. It's x, not e, because it's a neutral element. So this will be 2x. So from there now, from what we have now, we are going to have, we bring everything. We are going to have 2e. Take everything to the other side. 2x minus 2x plus 3. This will take care of this. So 2e is equal to 3. So e is equal to 3 all over 2. So the inverse element is equal to 3 all over 2. The identity element is equal to 3 over 2. So let's go ahead and find the inverse element. So we can say let S inverse be the inverse of x. Then what is the implication? X asterisk x inverse must give us the identity element. So if we do this now, using what is the definition, that would be 2x plus 2x inverse minus 3 all over 2 is equal to, that will be equal to the identity element. Then here I'm going to have 2x plus 2s inverse minus 3 all over 2 to be equal to 3 all over 2. That is the value of e. So if we cross multiply here, if we cross multiply there, we are going to have 2 into bracket 2x plus 2x inverse minus 3 to be equal to 2 times 3 is 6. So I'm going to have 4x plus 4x inverse minus 6 equal to 6. So 4x inverse, let's make the subject formula, will be 6. That will give us 6 plus 6 minus 4x. Then 4x inverse will be what? 12 minus 4x. So in this case now, we can bring out 4 here. I'm going to have 3 minus x. That will be 4x inverse. Divide both sides by 4. 4 will take care of 4. So x inverse, which is the identity element, will now be 3 minus x. And that is what we are asked to find. So let me just do the recap before we call it a day. So when I introduced binary operations, I said binary operations is just a unique way of combining two or more operations together to form a specific operations. And I said there are 6 properties that we are going to check under binary operation. The first one is the closure property. That is, whatever operation that we want to test, we must be sure that it is closed under a non-empty set. The second one, we talk about commutative property, where A asterisk B is equal to B asterisk A. Then we talk about associative property. That's when you have 3 elements from the set. So if you first pick the first element and with the second and the third, and if you rearrange the arrangement, are we going to get the same thing? If it is yes, then associative property will be satisfied. Then the fourth property is the distributive property. Under the distributive property, we said there are 2 operations that will be involved. We want to check if the first operation distributes over the other or vice versa. Then the fifth property that we discuss is called the identity element, which is otherwise known as neutral element. That is the element that does not really have effects on a particular element. And I said for addition, 0 is the identity element. Then for multiplication, 1 is the identity element. Then we now talk about the last property, which is inverse element. And I said we cannot find inverse element without you knowing the identity element, because the inverse element is the element, is what you are going to operate with that element to get the identity element. So I would love to stop the class for the day. So if you have further questions under binary operations, you can just type it at the comment section. I promise to go over it and solve the problem for you. Thank you, and God bless you.